Since I intended my hopper to mimic the flight that of a butterfly, but didn't, it can be described by Hooke's law and Newton's second law of motion. It is now time to examine how energy is utilized. To show you a qualitative energy analysis, and I'll discuss how to find the actual power output of the hopper. In my hopper, which is a rubber band powered, the process begins by cranking it. Kinetic energy is transferred and stored in the wound up of the rubber band. When the hopper is raised up before flight, gravitational energy is given to it, being expressed by the following equation. Note that friction is a factor in how much energy is wasted in this transfer. The moving wings give the hopper lift and thrust, propelling it forward and keeping it in the air, giving the entire hopper kinetic energy. Power is the change in the amount of kinetic energy, in this case of the hopper, for a unit of time. We can see it by the following expression, where the power equals to the change in the kinetic energy of the power over time. The potential energy of the rubber band can be measured with some creative devices, and gravitational potential energy can be calculated as the following. The gravitational potential energy equals to the mass times height to the gravitational acceleration, which in this case, it's approximately 9.8 meters per second squared. As I stated earlier, the expression of power, in this case, the change in kinetic energy will simply be the kinetic energy at the end of the flight and the time that would be of the flight. So power would be half times mass velocity squared over time. Having not worked the limited data, the only thing I could get was a gravitational potential energy, which